of what we heard today, like natural language processing on paper. Yay, thank you so much. Well, let's see if do we have the pictures? Can you see pictures?
Yeah.
Oh yeah. I'll overcome. But this is not what I would call computational. So people are making Herculean efforts here. We had some great conversations last night about how, and with some of the startups around here, about what you can do if you start within the kind of four corners of the laws it's traditionally been composed and instantiated. You can do natural language processing. You can try to gain some inference from meta tags. And you can do a great deal. But is it computational? Well, not really. The computation is sort of what everyone's struggling to bring to it. But what if we wanted to bring the law to computation? What could that look like? And that's really what I've been focused on for some time now through law.MIT.edu, is looking at computational engineering approaches and trying to apply that methodically and experimentally to law in different ways. So the reason I'm showing this photo is one thing that is common with engineering and trying to create human-built systems that do interesting things like flying is we look at what flies now, or we look at what is a contract or a statute or a judicial opinion now, and we think, well, can we just create like a bird that is mechanical? And then that was the whole life cycle of innovation in pre-aeronautics, I guess I'd call it, but it never really flew. Like the flapping of the wings and the aerodynamics of all that, it just doesn't quite work. It requires a little bit of a rethink in order to get things to fly. Interestingly, by the way, now that we know a lot more about how to engineer these kinds of systems, I actually did see an autonomous bird thing. Like they found out how to flap and how to get some pitch and roll and allow to have it take off and land and move right to left and gain and lose altitude. So we were able to do it eventually, but it certainly wasn't the first step. And it even raises the question, is that even desirable? Is that really what we want from law when it presents itself as something that's computational? Stanford Law and Codex, I think, do a very good job of tracking the state of technology in law. And here is here's how they've currently chunked most of the innovation that's happening now. And let me tell you, about half of it is digitization of existing traditional legal instruments and rules. And about half of it is coming at it a different way, looking at it more, extending it so that the information within an instrument like a contract or a statute is composed primarily as data that is well structured and can be recombobulated, if you will, in different ways. It could be assembled to display as a contract, or it could be interrogated for certain clauses across ranges of documents, because the underlying stuff or the matter is data primarily. This is good. So just as a little example, in the 90s I spent a lot of time with XML, and legal XML for court filings and for structuring contracts. That's a perfectly good way to structure data. It's still very document-centered. Nowadays, many of us prefer something like JSON, which is more like little objects, and it's much easier to work with if you're looking to do things with applications and services. This is more like what data looks like. In the United States, we've got the beginnings of light are starting to emerge with a federal register, for example, that gives notices of legal events. It has a nice API and presents itself as a service. It expresses itself as a service through a REST interface, and it's structured as JSON, so you can do lots of interesting things: sort, filter, search, compute. On the upper right here is something that I helped with the Securities and Exchange Commission some years ago. That's XBRL, Extensible Business Reporting Language. So publicly traded companies now do their filings, many of them do, as data. And the authoritative version of the filing isn't the PDF, but it's the data, and it can really help with transparency, it can help with enforcement, it's more efficient. So when we have legal information as data, what we want to do is not necessarily like flap the wings like a bird, but in this case, some of the types of things we might like to do would be to expose it through, as I was mentioning, interfaces like a REST interface, so that we can have interoperability of multiple sources of data and also legal activities, dockets and events that may affect terms of a contract, legal notices. These are all examples of types of activities that we can connect. And then how do we want to connect it? Do we want to sort of do it very manually? Well, sometimes. Do we want to allow for more automation? Yes. The idea of having some layers of the stack that can sense or have listeners on networks for certain types of activities or events that can then trigger other things so that we can connect like chains of applications. Now we're talking about transformation of what it means to practice law and and how legislators could start to look at promulgating law and tracking it, having better information about the performance. Is it achieving what we hoped it would achieve? Can we adapt and optimize it over time? Could that even be part of the law? With the XBRL and the Securities and Exchange Commission, it certainly is. They're updating their taxonomies and other aspects of how those legal processes for business reporting go based upon the performance of the system. So let me just talk a little bit more about data, because most of the time I spend isn't doing anything, that innovative or fun. I'm just fighting with data, and it sounds like everybody here pretty much is doing that too. We wrangle data, for 9 days, and then for 1 day, we can do something interesting. Once it's finally wrangled into some sort of shape, we can do something with. There's a better way. There is a better way, and others have embraced it, and I just want to talk about it for a moment. Get is a protocol that allows for complete version control, and it's really embraced by developers and computer engineers, and it allows for many people to use the same data and to contribute to the data through pull requests and merging different branches of a repository, and repositories that can be forked and extended, without at any point wondering what was the authoritative source or what is the current version. When I was practicing law, especially in the government, frequently the first half hour of a meeting when we were working with a lot of other governments and stakeholders was what version of this statute or this memorandum of understanding among 50 parties are we talking about. People would rifle through email and versions and just to figure out what on all of our comments. Git makes all that go away because it organizes from data first in a collaborative, distributed, interoperable system that has complete version control by hashing every version and making it available. It's synchronized across everybody's version of that data. I think Git is a really good type of capability to just embrace whenever we're doing legal things with data. Some people have heard the good news already. Like in Washington, D.C., the city government now has its authoritative version of the ordinances in the GitHub repository. That's where it is. And so you can discover it, you can search it, and sort it, and filter it, and oh my, you can do lots of things. And what else you can do is if you notice there's an error in there, or there's some little change that you think would be appropriate to the parking or the zoning or whatever, you can make a pull request. And this is a pull request that somebody made when they discovered that there was a slight error in citation to the Freedom of Information Act. They corrected it, made a pull request, and the people at the City Hall said, oh, good catch. They merged the pull request, gave credit to the person that helped them perfect the law. This is a civilized way to deal with law as data. And more to the point, it's a workable way. Okay, enough proselytizing about getting sensible about data. So having data is sort of a good first step, just so that we can have things that work. But In a legal context, it's not just about data, it's about what do we do with the data and who needs to do what. So I've come to believe that of all the different things we could be doing, 3 things would be especially useful. One is ensuring that all legal materials, there's at least a version of it that's in plain language, right, that anybody could read. You know, you could evaluate objectively based on, you know, asking people to read it and asking them what they thought it meant and saying if it's in like a 10th grade reading level, was it able to comprehend it or not. I think it also needs to be capable of being read by lawyers, and so a longer version that has more formalities, you know, need not go away, and that's still important. And it also needs to be machine readable. So 3 layers you can think of, what I call BLT sometimes, or the business or programmatic or operations layer, you know, people would read. A lawyer readable, like here's a Creative Commons, how they provide their licenses. There's a machine readable layer in RDF. There's a human readable layer that's just like a paragraph that says the essentials of the license. And there's a lawyer readable version, which is usually a few pages with all of the indemnification, the license terms, and all of that. We could compose and express legal instruments with these 3 layers very easily. I've done this with some governments and some law firms and nonprofits in the past. It works quite well. It anticipates what people will need later and allows more creativity. Well, let's talk a little bit more about the people. The people are the most important. And so for this talk, I said visualization, but in putting the remarks together, I realized it really has to do with the user interface and user experience. So visualization with, you know, different things you put in a dashboard is good, but that's only one part of what I want to highlight. When I used to teach law and technology in the 90s at MIT, my 2 required reading texts were The Design of Everyday Things and The Invisible Computer by Don Norman. There's a lot of different ways to look at this, but I still think these stand up. I was rereading them on the plane, and they're good. So, you know, just designing things so that they're intuitive and simple, including the experience of, you know, representing yourself in court or going through a legal process with getting married or landlord-tenant or business creation, just making it sensible and designed correctly. And the invisible computer part was ahead of its time then, but nowadays with chatbots and voice interfaces, this really does put less emphasis on becoming, you know, PhDs in the Byzantine workings of complex platforms, but just behaving as humans do and getting to the underlying point of it. This is an invisible computer user experience. This is available for law, and I've seen some interesting startups in Silicon Valley and in Toronto and elsewhere that are, and in New York, that are embracing this way of expressing their services, their legal services. I think this is good to look at. Now let's talk about AI. Who knows what this is?
It's from the Jetsons.
And who is she? What's her name? Rosie the robot. What a great show that was. And so, you know, this is still a pretty good concept of how people think about AI. We have like a robot, it may be software, but it sort of does things. You know, this is one vision of an autonomous AI system. There's another vision. So what's the difference between C-3PO and Iron Man? C-3PO, Iron Man.
Neither exist.
And so both represent things that exist. And I think C-3PO represents a sort of pop culture quick reference for a system that acts on its own without human review or approval, right? And that's one concept. Iron Man represents something different. So at the Media Lab for the last several years, we haven't talked much about artificial intelligence. You know, we certainly did for decades, but what we talk about from a human-centered approach is extended intelligence. And so at the Media Lab, we believe instead of thinking about machine intelligence in terms of human versus machines, or the machines running the show, we should consider the system that integrates humans and machines and extends what it is the humans seek to do. So if you look at the locus of autonomy with an Iron Man suit is a human, and it could also be Jeeves, whoever the guy's name was, but it's humans operating in concert whose capabilities are extended through autonomous and automated functions. This is a good way to look at it. I think the result. Some things I think are worth looking at as priorities in research and in innovation in the private sector are providing systems that enable predictable legal results. There's a lot of ways to do that, but I'd say looking for success measures, if a system allows people to have a pretty good idea of what the legal outcome would be in a certain circumstance, I would say that that is helpful and that is a good match for what technology can improve. And simple, intuitive usability is critical as well. And then finally, I mentioned here a little bit about algorithms, but being able to have things explainable and understandable is an element of extended intelligence as opposed to providing autonomy and privacy to machines. And finally, I just want to lay a concept on you, which is called formal verifiability. Does anyone here know what formal verification is? Computer scientists? We have a few people. So basically, well, especially Prolog, it's perfect for Prolog. So I know why Ken's raising his hand. But there's some systems that you can engineer so that you can formally verify exactly what every condition would be in every permutation of every circumstance. So that there aren't any anomalous results. So blockchain autonomous systems in on Ethereum using their programming language or smart contracts are not capable of formal verification. You get surprising results like the huge implosion and the fraud that occurred with DAO Hub because someone was able to hack it and steal some money. Systems that are formally verifiable are systems that are reliable and can be trustworthy because they're capable of being put in a test harness and a simulator, and we can see every single potential outcome for every combination of inputs. Everything doesn't require that, but when we're looking at voting systems and civil liberties and the essence of some of the core civilization things that law also provides, this is a concept that's worth having in the back of our mind. And for more easy breezy things that are maybe like a small dollar contract, maybe more loosey-goosey systems may be more efficient and appropriate, but a sense of proportionality is useful, and it's good to know borrowing from engineering fields, we can have very high-grade reliability and predictability about results, like reliable, predictable, trustworthy legal results when systems are computational and formally verifiable. And we'll need some sense of layers eventually too. So we can start to slot our innovation to like the communications layer, the network layer, the UI layer, and make sure that things can operate in their lanes, but also interoperate up and down layers. That would be good. There's lots of stacks and frameworks that we could draw from. But what would be the layers for the law? How can we ensure everything is operating well, but is programmed at the right layer of the stack? So that as we transform civilization to more of a digital online enterprise, the law is a first-class citizen in that we've engineered ourselves so that we can operate and fulfill the purpose of the law appropriately within broader markets and societal systems. So if you want to talk more about any of that stuff, you can reach me right there, and I'll be here through the end of Saturday, and I'd love to talk to all of you. Thank you.